in the periodic table, we have the majority of it made up of metals and a smaller portion of it of its opposite, or not its opposite, but just non-metals. And they're kind of separated by a line. We call it a staircase. And so I'm going to draw in the staircase now and then show the difference in the metal and non-metals on the periodic table. Okay. So maybe it's hard to tell. Say no. So I'm going to highlight. So this little staircase of elements separates our metals and non-metals from one another. And so our non-metals are going to be in the upper right-hand side along this staircase right here. Highlighting these in pink. And oddly enough, there's one over here, hydrogen. And then our metals are the rest of the periodic table, which I'm going to be honest with you, is pretty big. And so I'm highlighting it in green. And then it also includes these ones that have been separated down and kind of shoved at the bottom, the lanthanides and actinides. And so we have our metals on this, taking up the majority of the periodic table, and our nonmetals in the upper right-hand corner plus hydrogen. And some people argue that that hydrogen right here should actually be right here next to helium and the rest of the nonmetals. We'll talk a little bit later in this lecture series about why it is where it's placed, based on the fundamental organizational structure of this around where electrons are. But so our nonmetals that are in this upper right-hand part of the periodic table share some similar properties with one another. They tend to be kind of brittle and dull, and they are insulators. It means they don't conduct energy or like heat or electricity, so energy. So they don't conduct. And they tend to form compounds rather than exist as just atoms on their own. So there's usually these elements are bonded together overall. A lot of these are solids, or sorry, not solids, gases at room temperature. One is a liquid, bromine, right here, is a liquid at room temperature. So then our metals, on the other hand, they their properties, and this is a large classification of elements, right? So they tend to be shiny. And as you're probably used to just with the metals in your daily life, they're shiny, and they are they could bend a lot of times. How hard they are kind of varies across them. Some are really hard and some are really, really soft, like sodium or lithium. I could just use my fingernails to break it apart. And they conduct heat and they conduct electricity. And these are typically going to be solids at room temperature, with the exception of mercury right here, which is going to be a liquid. So those are our metals, different from our non-metals. And in between the two is a group of elements that I've highlighted blue that are called the metalloids. Oh, let's change the color. And so these really have characteristics of both metals and non-metals. So they're really just kind of in between the two, so much so that we actually call them their own separate thing. And so metalloids in general tend to have properties like they'll be shiny but brittle, right? So kind of borrowing a property from each. They also tend to be semiconductors as well. And so they can conduct electricity, but just not as well as their metallic counterparts overall. So thinking about semiconductors, like silicon is right here, and silicon is a metalloid, so it kind of has these properties that kind of make it well suited to that role. Right. So just where something is on the periodic table will tell you if it is a metal, non-metal, or metalloid. Now we're going to look at the information that we get from the kind of different groups. And so I'm going to just point out their names here for some of them. So we have we don't have names for every single one of our groups, which are the columns. So we do for the first two, though. The first column, so group 1, is our alkali metals. And our second column, group 2, is our alkaline earth metals. Just kind of a mouthful. Then our next set of rows from scandium to zinc, so there's 10 of them, are our transition metals. And we don't have names for the individual columns for these. We just kind of think of that group as the transition metals. But like this one right here is our lanthanide series. And the one below it is the actinides. So then as we go back into our representative elements in the last 6 groups of the periodic table, not all of these have names. And it's because like if you look at them, a lot of them are like, oh, we have, like in this column right here, we have a couple nonmetals, a couple metalloids, and a couple of metals as well. These metals, right, that are kind of after the transition metals, which stop right here, are usually called the post-transition metals, or just metal. But a couple of these have names. The last column is called, which is group 8. It's called the noble gases. They all are gases at room temperature, and they are really, really inert. They're not very reactive at all. And then here we have group 7, we call the halogens. And so those names and those columns also kind of come with some unique properties about them, which we'll talk about next.